In this study skill, we are going to be talking about metacognition and how that can improve your ability to learn. So what is metacognition? Metacognition is awareness and understanding of one's own thought processes. So an example might be, maybe you're bad with names. Metacognition would be understanding and realizing and being aware that you are bad with remembering people's names, and then doing something to fix that. For example, when I introduce myself to someone and I shake hands and they give me their name, I might say back to them, "It's nice to meet you, Jessica." So every time that I introduce myself, I'm aware of this inability to remember people's names, and so I say their name back to them to keep that information in my brain. So in this first part, we're going to talk about mindset. So you should have already taken this mindset quiz. If you haven't, go back to the study skill page and download the file and take a minute, pause the video, and take the mindset quiz. For each question, you just place an X wherever you either agree, strongly agree, disagree, or strongly disagree for every question 1 through 10. So take a moment to do that if you haven't already. Now, once you've taken the mindset quiz, go ahead and score it. So based on where you put your X for each question, you get either 0, 1, 2, 3 points for that. Okay, now this is not part of your grade, so don't change your answers. Answer honestly, but find the sum of all of your points and take a moment to enter your score now. So what does your score mean? Well, if you scored between 23 to 30 points, that means you have a strong growth mindset. If you scored 22 to 17 points, that means you have a moderate growth mindset. If you scored 16 to 11 points, you have a moderate fixed mindset. And if you scored between 10 and 0 points, you have a strong fixed mindset. So what's the difference between a growth mindset and a fixed mindset? We're going to watch a little video to explain that.
Did you know there's a powerful relationship between what we believe about how we learn and our actual achievement? Dr. Carol Dweck studies students' beliefs about intelligence. What she found is that students generally hold one of two very different beliefs about intelligence. Some students have what she calls a fixed mindset. This is the belief that intelligence is a fixed trait that doesn't change much. So like eye color, these students believe you're born with a certain amount of intelligence and there's not much you can do to change it. Other students have a very different belief about intelligence. They have a growth mindset. They see intelligence more like a muscle. They understand that when you put in effort, you can get smarter. What we now know from study after study is that the more students have a growth mindset and believe that they can grow their intelligence, the better they do in school. Students with a growth mindset do better in school because they approach learning differently than students with a fixed mindset. For students with a fixed mindset, their goal in school is to show how smart they are, or hide how dumb they think they are. This makes sense, right? If you think you're just born smart or dumb, you want to make sure you show that you are smart. So this makes fixed mindsetters much less likely to ask questions in class or seek out help from peers or teachers, because that would involve showing that they don't know something. Students with a growth mindset, on the other hand, have the goal to learn, so they're more likely to ask a question if they don't understand, or to seek out help, or try a new strategy if they are struggling. When it comes to the amount of effort you have to put forth, students with a fixed mindset and students with a growth mindset see that differently as well. Those with a fixed mindset actually see effort as proof of low ability. They think that if you have to try hard, that means you aren't very smart. whereas students with a growth mindset see effort as the way that you get smarter. How students react when they are faced with a challenge or setback in their learning is what really differentiates those with a fixed mindset and those with a growth mindset. Students with a fixed mindset will think that they are not smart and will likely give up on a task. Those with a growth mindset tend to work harder because they see it as an opportunity to learn and grow their intelligence. So if we can all grow our intelligence, are we saying that all students have equal ability? We aren't saying that everyone has the same level of intelligence. Having a growth mindset doesn't mean that you believe everyone has equal ability in every subject matter. It also doesn't mean that we believe some students aren't more talented in certain subjects than others. It means that you believe that no matter where a person is now, they can always improve with effort, good strategies, and help. And that's the number one piece of information you should take away from this lesson. No matter where a person is now, they can always improve with effort, good strategies, and help.
So now that you've seen the video about growth mindset, I want you to reflect on what you can do to release that growth mindset if you have a fixed mindset, or even improve your growth mindset even if you already have a growth mindset. So this would be things like, say, instead of saying, "I'll never get this," what could we say instead? Or, "I give up," or, "I'm not a math person." I hear that a lot being a math teacher. "I'm just not a math person." Or, "This is too hard." Or, students often relate mistakes to being dumb. So if they get a question wrong, they automatically assume that they are dumb. So what can we think instead? Try thinking instead of, "I'll never get this," "I don't have it yet." Learning takes time, right? If we already knew the information, we wouldn't need to go to school for it. Instead of saying, "I give up," think, "I need to try a different strategy." So maybe the approach you're using isn't working. Can you change it up? Instead of saying, "I'm not a math person," think of learning as exercise. Just like athletes go to the gym every day to build their muscles. No, they don't sit there and do squats on the football field or, lift a barbell while they're throwing a football, but they exercise those muscles and strengthen them so when they need to use them, they can. Instead of thinking this is too hard, think this may take some time and effort, right? So you have to put in the time to learn new things. "I made a mistake, I'm dumb." Turn it around. What am I missing so I can learn from it? Okay, what can you find the error and learn from that error? How can you change it so you don't do that again? All right, in this next part, we're going to talk about your understanding of how people learn. So what I want you to do is take a minute and pick one of these 5 things that represents the most important factor in successful learning. There's only one correct answer. This is not a trick question. And keep in mind that if you pick the wrong one, you might be studying in the wrong way. So the first one is the time you spend studying. Do you think that is the most important thing when learning? Do you think number 2, the intention and desire to learn, right? So maybe you don't understand it, but you have a strong will and desire to learn the information. Do you think 3, paying close attention to the material as you study? Do you think attention has something to do with learning and retaining information? Number 4, learning in a way that matches your personal learning style. So you may have heard learning styles are, some people are very visual learners, some people are kinesthetic, meaning they have to do it. Some people are auditory learners. Do you think that makes a difference in your ability to learn? Or number 5, what you think about while you study. Take a minute to vote now. Just type 1, 2, 3, 4, or 5 for what you think is the most important. Alright, let's go ahead and go through these different ideas, the 5 that we mentioned on the last page. Do you think it's the time that you spend practicing? So true or false? Practice makes perfect. Vote now. The answer is false. So you hear that phrase a lot, practice makes perfect, but it's actually not true. It's tough because this is so close to the truth. Practice doesn't make perfect. Practice makes habit. There are good habits and there are bad habits. So if you practice doing something the wrong way, you're forming a bad habit. Think about learning to play an instrument or, ballerinas. If you practice with the wrong technique, then you might as well not have practiced at all. Yes, it's true that learning takes time. However, the way you spend that time is more important than how much time you spend. So it's a myth that practice makes perfect, and the more time you spend, the better you'll be at that task. That's not true. So we already mentioned what was wrong with that statement. But what might be some bad techniques when studying math? Well, one of the big ones that I see a lot is being distracted. Multitasking, watching a show while you're trying to do your math homework, or studying while you're trying to make dinner and you have kids. Some other things would be, have you ever noticed that you get A's and B's on your homework but then fail a test? Well, the question is, do you sit there with a friend who helps you, or a tutor, or you're watching a video and you're doing it simultaneously, step by step with that video? Well, you have someone there prompting you along the way to do these problems. But what happens when you go into a test situation and that prompt is removed? A lot of the times students forget how to do the steps because they've never practiced on their own. So it's important that you are doing these things on your own and then asking for help when you get stuck. But then again, making sure that at some point you can accomplish it on your own without the prompting. So what might make better study habits? Well, obviously remove the distractions. Try to go somewhere that you can work without a phone, TV, kids, if possible. Make sure that you can explain what you did at each step and why you did it to yourself or maybe even somebody else. They say until you can teach to somebody else, you have not mastered a concept. So that's an important part. Can you explain step by step what you're doing and why you're doing it to somebody else? All right. Now, let's look at this next thing. If you answered 2 or 3, we're going to look at the following. So there was an experiment done by JENKINS and HYDE in 1969. They had 5 groups of students and they were given 24 words like hot, desert, happy, cold, like all these different words. There's 24 words. And each group had a different set of instructions on what to do with the words. One variable that was being measured was the kind of learning that was happening. So students in the group 1 and group 2 were warned about what would happen. They were told they would need to recall as many of the 24 words as they could. So this is what's called intentional learning. So they knew they needed to try to remember the information. They were focusing on it. It was intentional. Now, these other groups, 3 and 4, were not told what they were going to have to do with these words. So they didn't know that there was going to be a recall at the end of seeing the 24 words. The other variable that was being measured was the level of processing. So they grouped them. So group 1 and 3 had what was called a shallow shallow level of processing. So they were just asked, when given these 24 words, to check if the word had an E or not. So like heat has the word E. You'd think, yes, it has a yes or no answer. Yes, it has an E in it. Or cold. No, there's no E there. Okay. The other set of groups, so group 2 and group 4, were told to think about the pleasantness of each word. So does this word make you think of something pleasant? Okay, that's a deeper level of thinking because you're connecting it to your own memories and your own experiences and deciding whether or not that word is pleasant or not. So what happened in this experiment? Oh, and I should also mention that they had a control group. They were just told to learn the words by whatever means necessary. Okay, so the results of the study showed that intention did not mean anything for learning. So whether the people were told they would have to recall it or not told they'd have to recall it, it didn't make a difference in the results. They had the same result level. But what did make a difference was the difference between shallow level of thinking and a deep level of thinking. So the people in groups 2 and 4 did the best. The ones that had that deep level of thinking, no matter if they were told that they would need to recall the words or not, they had the best results. What does that mean for our original question, right? So I asked you to pick 1 through 5, which one was the most important? Well, we ruled out number 1 because it doesn't matter the amount of time you spend if it's not quality time. We ruled out number 2 and 3 because it doesn't matter if you have the intention or you are paying very close attention to some words or studying. Only the level of processing did. So it doesn't matter if you have that desire to learn, you want to, or if you're really paying attention, because again, it's about what you think about when you're learning. For number 4, we can rule that out because lots of different studies have showed that you can find one study that says, yes, learning styles make a difference. You can find another study that proves, no, it makes no difference at all. And it's true that you might have a preference for a particular learning style, but it's good to be well-rounded and learn how to deal with any learning style. You don't know what type of professor or boss you'll have in the future, so it's good to be flexible and learn how to deal with all the different learning styles. So the answer here is actually 5. It is what you think about while you are studying. Okay, the level of processing is what makes the most difference to study. The deeper level of processing, the more likely you are to remember what you are trying to learn. You're building stronger synapses in your brain, making the recall easier. Okay, so how do we get that deeper level of processing? The first thing is elaboration. How does this concept relate to another concept? So, how does prime factorization relate to finding the greatest common factor? Can you tie those concepts together? Okay. Distinctiveness. How is one concept different from another concept? So not only thinking about how concepts are similar, but how are they different? When do I use one process over another? When do I need to find a common denominator and when don't I? Okay, so for example, multiplying and dividing fractions. I do not need to find a common denominator. But when I add and subtract fractions, I must find a common denominator. Okay, number 3, make it personal. How can you relate the concept to your own personal experience? For example, maybe you struggle with the word vertical. So I talk about vertical and horizontal sometimes. Well, think about if you enjoy basketball. So you like basketball. A lot of times basketball players have what's called a vertical jump. They measure how high a basketball player can jump. That is the vertical jump. So vertical means to go up and down. Can you relate our math concepts to your own life? And then number 4, you need to have appropriate retrieval and application. So you need to practice taking a quiz or test in the way that your teacher expects you to know the information, right? So lots of research shows that retrieval practices improve memory and learning. The more times you try to recall information, the stronger the connections are in your brain. So even though you don't like it, quizzing and testing yourself, that's the key. It's important to try to recall the information without any aids. So no friends, no tutors, no videos, no notes. Can you figure it out on your own? Just practice recalling. Try problems like it's a quiz or a test. Try it in a quiet space like you would when you're taking a test. And don't get discouraged after your first attempt. The key is to keep trying on different days. There was a study done that showed if children work on math 15 minutes a day, it can increase their skills in math by half of a grade level or more. So that's something to think about. If you're working on math every day with a deeper level of processing, it can improve your recall ability, reduce anxiety while you're test taking, and give you a better overall grade in your math and understanding. Alright, so what are some problem-solving steps that you can use that will help you to work through math problems and have that deeper level of thinking and awareness while you're working? The first step is to understand the problem. That means ask yourself, what is the question asking you to find? What do I know? What do I not know? The next step is devising a plan. So there's lots of different ways that you can devise a plan. You can guess and check. You can try to relate it to a similar problem. You can use a formula. You can use a picture or a table. There's lots of different plans, but you pick one plan, then you carry out that plan. So you try it out. If you get stuck or it doesn't seem to be working, you might have to go back up and devise another plan and try again. That is part of the mathematical process. Okay, some students think that if their plan didn't work, again, they think they're dumb, they think they can't do it, and that's just not true. Okay, that is part of the mathematical and scientific process of learning and discovery. So after you've carried out your plan, one of the most important steps is the look back or reflection. So you get an answer. Can you check your answer? Is it something that you can check to see if it works? Does it seem reasonable? Does it make sense? What is it that you found? What are the units of that problem? Could you have done it a simpler way? One of the things that I see the most often in math is students get an answer and they say, well, that's what I got. But the question is, does it make sense? For something like time, does it make sense to have a negative time? Well, no, we're not time travelers. For something like a car payment, does it make sense to have $1 million car payment every month? No, that doesn't make sense. So again, once you've completed the reflection part, you might have to go back up here and devise a new plan if that answer didn't make sense. So this is like a cycle that you might have to go through a couple times before you get to a solution and your solution makes sense. So we have this quote, typical problem solving involves communicating, gathering information, organizing the information, and implementing a plan. Okay? So metacognition really is about reflection. That is one of the most important things, is being aware of what you think about when you're thinking. So it's best to reflect often and regularly, practice within each problem, practice reflecting your overall understanding of math concepts, your overall understanding of your ability to learn. We have to train our brains to reflect on the way we think, and thus it takes practice, and we have to do it in a variety of ways. Sometimes to understand your own learning, you need to see the relationship to other people's learning styles and experiences. So that's the social and collaborative part. Reflection in the moment can break bad habits and allow you to shift gears and recognize unproductive strategies. Then evaluate the outcome. Can you follow along with the steps that you took? Can you explain it to someone else clearly? Did the method work? Did you get feedback from a peer or instructor? Can the skill be transferred to another context? So there's a lot to think about with metacognition, but the main thing that you need to do is to be aware of what you're thinking about while you're thinking, and use some of the strategies from this video. So I want you to now type a sentence about one thing that you will take away from this metacognition video, or something new that you didn't know, and write it in the quiz now.